All right, so in a previous video, we did a single family dwelling calculation. So I just put part of it up on the board here in the total because what I want to look at here, we didn't select the actual overcurrent device or the service conductors, as well as any of the branch circuit type circuit breakers, etc. So let's just take a quick moment to review. So if you need to review the actual calculation, you can go back to the previous videos. So in the previous video, when we calculated up the area, it was 10,000 watts. We had to put in 7,600 watts for the 16 kilowatt range. The 6 kilowatt dryer went in at 25%. The 4.5 kilowatt domestic hot water tank went in at 1,125 watts. The 7.75 kilowatt pool heater went in at 100%, as well as the 20 kilowatt electric heater went in at 100%. We totaled up all those watts, and the demand for the service in watts was 47,975 watts. So at this point now, we have to turn it into amps, and then where do we go to select our breaker, our main breaker, and our service conductors, etc. So let's just take a look at Rule 8-100. So let's see here, we'll get up on the desktop. So up here, hopefully you have your code books open, get them open to Section 8, Rule 8-100. So when you've done your calculation and you come up with this watt total, the next step is to turn it into amps. So Rule 8-100 gives us guidance on our voltage divisors. 8-100, current calculations. When calculating currents that will result from loads expressed in watts or volt amperes to be supplied by a low voltage AC system, the voltage divisors to be used shall be 120, 208, 240 volt, 277, 347, 416, 480, or 600 volts as applicable. So when you're doing single-family residential houses, generally in a question you're going to be giving the voltage. So in this case, our voltage is 120, 240 volts, single phase. All right, so your voltage divisor will be 240. So on a lot of equipment, you'll see something like 125, 250 volt, etc. This is the rule that tells us what numbers we use to use as voltage divisors throughout the whole code book. So really, it's just a rule you have to be aware about, and then when you do your calculations after a while, you don't really come back and reference it at all. All right, so we'll take the 47,975 watts, we'll divide it by our 240 volts, and that will give us our minimum ampere rating. There we come out with 199.9 amps. All right, so we've looked at 8-104 before. In a previous video, let's just quickly take a look at that rule to make sure we comply with it. So it says here in subrule 1, the ampere rating of the consumer service feeder or branch circuit shall be the ampere rating of the overcurrent device protecting the circuit or the ampacity conductors, whichever is less. So when we select the conductors or the breaker, the rating of the circuit will be whichever is less, the breaker or the wire. That's all. It's just a statement there. 2, the calculated load in a circuit shall not exceed the ampere rating of the circuit. So that is our calculated demand. We cannot be less than that. Our circuit breaker can't be less than 199.9 amps. Or the conductors. Then we have subrule 3 that says the calculated load in a consumer service feeder or branch circuit shall be considered a continuous load unless it can be shown that in normal operation it will not consist of the requirements in either A or B. Well, this tells me then that is a continuous load. But let's go take a look here what 8-200 subrule 3 says about the calculation that you perform in the single family dwelling. So 8-200 subrule 1 was the calculation that we did. 8-200 subrule 1A was the calculation we did. We compared it to B. We were far above the 24,000 watts. That became the minimum value. We turned it into amps. Then when you come down to subrule 3, it says, notwithstanding rule 86302, the total calculated load in accordance with either 8-200 subrule 1 or 2 shall not be considered to be a continuous load for the application of 104. So what that means is you don't have to worry about whether the circuit breaker is rated for 80% or 100% because it's a non-continuous load. So what that means is if I have 199.9 amps of non-continuous load, if I could buy a 199.9 amp breaker, that's what I could use. There's no 80% loading, etc. You don't have to worry about it. The reference to 86302 is the vehicle charger. If you have a vehicle charger, so within the service there is continuous loads. But the whole actual service is not considered to be a continuous load for the application of 8-104. But I can tell you that is a continuous load, that is a continuous load, and that is a continuous load on the branch circuit side. So when you go into the branch circuit selection, then 8-104 does apply. All right, so now what we have to do is take a look at this rule, and then we've got another table we can look at. So that's what we're going to do on our next video. So in this one, we've confirmed our watts. We applied 8-100 for our voltage divisor. We got it to 199.9 amps. We looked at 8-200 subrule 3. We know that is a non-continuous load. Now we can go to 4-004 and we're going to select our conductor and our breaker. So we'll see you in the next video.